Hello and welcome back for lesson 3 video. This is all about division of polynomials. So we've been learning about polynomials in chapter 3, and now we're going to learn about dividing them and the remainder and factor theorems to go along with that. So the first method of division is going to be long division, and it's going to be very similar to how we've divided other numbers in our life. So let's say we had the number 236, and I wanted to divide 236 as my dividend. And I wanted to divide that by 3 is my divisor. I write it like this, and I ask myself, how many 3's can go into 2? None. How many 3's could multiply to make 23? I could get close by saying 7. So 7 times 3 is 21, and I'm going to subtract those 21 away. And then I have 2 remaining, and then I'm going to bring down my 6, and I'm going to say how many 3's could multiply to make 26? And that would be 8, which is 24, and I subtract those away, and then I find out that 2 is my remainder. Okay, so we're going to do something similar. So let's say I wanted to divide 2x squared minus 7x plus 3, this polynomial, it's a trinomial, and divide that by x minus 3. So I'm trying to figure out what can multiply by x minus 3 to get to this polynomial. X minus 3 is my divisor, and 2x squared minus 7x plus 3 is my dividend. So I want to know how many of these x minus 3's it takes to get to this polynomial. So I'm going to ask myself, what do I multiply x by and the x minus 3 to get to 2x squared? So I'm going to walk you through this. So we're saying 2x squared minus 7x plus 3 divided by x minus 3. So I'm asking, what do I have to multiply x by to get to 2x squared? I have to multiply by 2x. So I'm going to multiply 2x times x, which is 2x squared, and then 2x minus times a negative 3, which is a negative 6x. And then when we do long division, we always subtract this. So we're going to subtract and subtract, which makes that an addition. And then I'm going to add straight down. So 2x squared minus x squared cancels out, which is what we want. And then we have a negative 7x plus x is a negative x. I'm going to bring down my 3. And then I'm going to ask myself, how many x's, what do I have to multiply x by to get to a negative x? I have to multiply by a negative 1. So I'm going to do that. A negative 1 times x is a negative x. A negative 1 times a negative 3 is a positive 3. Then when I subtract them, this becomes positive and negative, and they add to 0 and 0. So 0 is my remainder. So I can say that x minus 3 times 2x minus 1 equals the polynomial 2x squared minus 7x plus 3. I actually could have just factored this, but this is how you do long division. Let's find another one. Let's find the quotient. So in the last one, 2x minus 1 is my quotient. It's the result of dividing. So find the quotient and possible remainder when the polynomial of x squared plus x minus 6 is divided by x minus 2. So I have to multiply x times x to get to x squared. So I'll have x squared minus 2x. And then when I subtract, I get subtracting and addition. So those cancel. That's what I have to do is I have to get those to cancel, and then I'll just combine the others. X and 2x is 3x. And I bring down my minus 6. Then to get from x to 3x, I have to multiply by a 3. So this is going to be plus 3. And then I'm going to multiply that. 3 times x is 3x. 3 minus times a minus 2 is a minus 6. And when I subtract and make that an addition. Those add to 0 and those add to 0. So the quotient is x plus 3. So that tells me that x minus 2 and x plus 3 equal x squared plus x minus 6. And this division algorithm just explains what we just did with the polynomial and the remainder. So let's try a little bit bigger one. It says find the quotient and remainder when the polynomial here is divided by 2x minus 1. So to go from 2x to 6x cubed, I'm going to have to multiply by 3x squared. So 3x squared times 2x is indeed 6x cubed. 3x squared times a negative 1 is a negative 3x squared. And make sure you're subtracting underneath the same power. So if there was no x squared term, right, we would have 0 subtracting a negative 3x squared. So just make sure that they line up because you have to combine like terms. So this will be subtracting and subtracting, which changes the sign here. So that goes to 0, a negative x squared plus 3x squared. We end up with 2x squared, and I bring down the next term. So to go from 2x to 2x squared, I just need to multiply by an x. So that'll be 2x squared minus x. And of course I have to subtract, changing the signs. So this adds to 0, and I have a negative 3x plus x is a negative 2x, and I'm bringing down my 1. And then 2x times what gets me a negative 2x? Just a negative 1. This would be a negative 2x plus 1. And we subtract them. Right? We change the sign. So that goes to 0 and that goes to 0. So there's no remainder. So this is my quotient. Sometimes you will have a remainder if it doesn't divide evenly. That's very possible. There is another method called synthetic division, which actually makes this whole division thing more efficient. This type of division is more simplified versus the long version. So if your divisor, what you're dividing by is x minus c, then you start with just c and only the coefficients for the dividend. So we're going to go back here to original example. So I'm dividing by x minus 2, so c is equal to just 2. So I'm going to do 2 here. And my coefficients are 1, 1, and negative 6. And they have to go in order. I have an x squared, so the next one would just be x, and then my constant. So I've got 1, 1, and a negative 6. And we separate it like this. Your divisor's over here. So how synthetic division works is your very first one comes straight down. Your very first coefficient. And then you multiply 2 times 1 and you add it. So 2 times 1 is 2 plus 1 is 3. And then you do 2 times 3, which is 6, and you add these. A negative 6 and 6 is 0. And this would be my remainder. There's no 0. So that means my quotient is 1, which is just an x, plus 3. You start with the far right, and that's your constant, and then you would go to your x term and your x squared if you had one, and your x cubed. Let's do a couple more examples here. Using synthetic division to find when 6x cubed minus x squared minus 3x plus 1 is when divided by x minus 1. So that means c is equal to 1. So 1. And then my coefficients are 6, a negative 1, a negative 3, and a positive 1. I bring my first coefficient down, and I multiply 1 times 6, and it goes here. And then I add. A negative 1 and 6 is 5. And then I do the next one. 1 times 5 goes here. And I add. A negative 3 and 5 is 2. And then I do it again. 1 times 2 is 2. And I add, and 3 is my remainder. So this is the same as 2 is the constant. It's a positive 2. This was a positive 5. So that's a 5x. And then this was a positive 6, and that'll be an x squared. And then that's a remainder of 3. So x minus 1 is not an even factor of this polynomial, or else the remainder would be 0. Up here, x minus 2, right? Or 2 itself is a 0, right? An x-intercept, because it was an even factor of x plus 3. Okay, let's look at the remainder theorem. The remainder theorem says when a polynomial is divided by x minus c, the remainder is equal to the value of p of c. The term x minus c is a factor of a polynomial if and only if p of c is equal to 0. So it says use synthetic division to evaluate p of a negative 2. Okay. So that means p of a negative 2. Negative 2 is my c. So I'm going to do a negative 2 here, and then I'm going to write 3 is my coefficient. I don't have an x cubed term, so I have to have a place value of 0 for that. Then I have a negative 1, a 3, and a negative 1. So I bring down my 3. A negative 2 times 3 is a negative 6, and I add those to get a negative 6. A negative 2 times a negative 6 is a positive 12. I add to get 11. A negative 2 times 11 is a negative 22. I add those to get a negative 19. And a negative 2 times a negative 19 is a positive 38. And I add those to get a remainder of 37. Okay. And so my remainder is 37. So if I were to put a negative 2 into my function, we would have 3 times a negative 2 to the 4th minus a negative 2 squared plus 3 times a negative 2 minus 1. So this would be 3 times 16 minus 4 minus 6 minus 1. So that would have been 48 minus 11 is 37. So that checks out. So your remainder using synthetic division is the same as evaluating your function at that value. So it says determine whether x minus 1 is a factor of 2x cubed minus 4x plus 2. If it is a factor, then when we divide using synthetic division, c is equal to 1. If my remainder is 0, then it is a factor. So my coefficients are 2. I'm missing an x squared, so I have to put a 0 as my place value. I have a negative 4 and then 2. So I bring down my 2, I multiply it by 1, and it goes here, and I add. 0 plus 2 is 2. Again, 1 times 2 goes here, and I add, and I get a negative 2. 1 times a negative 2 is a negative 2, and I add and I get 0. So because my remainder is 0, because my remainder is 0, then yes, x minus 1 is a factor of 2x cubed minus 4x plus 2. And so x minus 1 times this piece right here, which is 2x squared plus 2x minus 2, is the quotient. It's what multiplies to make my original polynomial, 2x cubed minus 4x plus 2. Isn't that so cool? Okay. Catch me back for the next lesson.